So a quick introduction about us, and then we can dive into the workshop. So I'm Ido, this is Eduardo, my co-founder. I'm based in New York, he's based in Mexico City. Yeah, maybe go.
Yes.
All right. So we met together in a master's. Then we went to different ways. Eduardo went to be a data scientist. I went to be a data engineer. And we saw this gap in the domain where, like there's lots of difficulties. You want a POC in Jupyter, and then you kind of want to, push it into production or do the modeling faster, templatizing it. We'll see tons of cool stuff today. And we really believe in open source, so that's a big part of who we are and what we do. Anything to add?
Yeah, so we met at our master's degree about 6 years ago. We became friends, and 3 years after we started Plumber. We are a small company. It's 4 people right now working on open source. And it's been great to be working on this for 2 years now. So we're really excited to show you what we've been working on. So it's going to be like a deep dive. We'll show you many things, like show you some tricks to use Jupyter notebooks more effectively, like debugging, testing, running experiments in parallel. So it will be a lot of fun. Now I think we can start with the setup, right?
Yeah.
Just like, okay. So please, everyone, go to this URL right here, and then click on this Start Workshop. It will take a few seconds to load, and then you'll see Jupyter Lab on your browser. And once everyone's there, we can start.
Yeah, so it's all managed. You don't need to install anything locally. It's hosted in GitHub, so you can go back to it later if you want and actually redo some of the stuff here. If anyone has a problem, just raise your hand to help.
Maybe in the meantime, while people are getting the Jupyter Lab up and running, we can get introduction to the new people.
Yeah, so we did introductions before you guys joined. So maybe who didn't introduce themselves? You. Okay, 4. So let's do left to right. So you can go first. Say your name, your profession, what you do, and locations.
Okay. Dave Gallagher, data scientist at Clever Devices. We make intelligent transportation systems, a lot of which are running next door at the Port Authority. They're on the buses. All the buses going around and running their stuff.
That's awesome. Thank you. You can go.
Hi everyone, I'm Emily. I'm a data scientist at IBM. I graduated from undergrad last December.
Awesome. And where are you located? Here?
Oh, I'm located in New York, yeah.
Cool. You as well?
Long Island.
Long Island. Awesome. And you can go.
Hi everybody, I'm Seth. I'm a co-founder of the industrial Internet of Things startup here in New York. We collect data from machines to try to make sense of it for enterprise customers.
Awesome.
My name is Matthew Beckermont. I'm working at CVS Health as a data scientist. I'm located in Westchester.
Cool. Okay. Another CVS data scientist. So don't know if you guys know each other before.
Giant.
Yeah, I am.
I know like 2 people.
Okay, that's fair. So raise of hand. Who didn't get the workshop?
We were missing one introduction.
Yeah, like this link. Okay, cool.
We are missing one.
Oh, yeah. Please introduce yourself.
No, it's
Everyone, I'm listening. I live in New York, and I work for the University of Chicago Crime Lab. We're not
Guys, you are missing your introduction. Set. Do you have problems or something?
I was just wondering that I haven't used the Wi-Fi.
Oh, so if anyone don't have the Wi-Fi, it's right over there. You have the password. You log in as a guest and put the code. Yeah, I'm sorry we missed your introduction. Could you repeat it, please?
I'm Melissa Mayfield. I live in New York. I work for the University of Chicago Crime Lab. We're a nonprofit that does gun violence prevention research.
Awesome.
nice. I spent 1 year at the University of Chicago in the crime lab. I think they were my neighbors. I don't remember.
Oh, yeah?
Yeah. I was part of the data science for social good program like a long time ago.
Yeah.
All right, so let's start. So what we can do is go to the GitHub page, if you didn't so far. Then you can click on Start Workshop, and that would launch this Jupyter notebook.
Can you use me on your page?
Yes, yes. Right, so just to set the background a bit, what we learned today, we'll separate it into two sections of like 35-40 minutes. Then we'll have a small break. And the first part is how to run experiments, how to parallelize your work, basically getting to the best model at the shortest amount of time. Once we're done with the modeling work, we need to compare the results and understand, our performances, the local curve and F1 and all of these scores. Then we'll have a short break, and then we'll dive into how do you debug the notebooks. A big use case we've seen so far is like someone's running in production, it's a huge notebook, let's say it's like a deep learning model, runs all night, then you come on, in the morning and something broke. What do? Do you debug it with like a sample data set, or do you like run it again? So we have a really cool tool for that. Also, profiling the notebook, so how much CPUs it consumes, how much RAM it consumes. And then how can you scale your experiments? Let's say you want like a 62, 64 CPUs machine. The laptop can't really handle it, obviously. How can you spin up the machine without all of the infrastructure, security management, user management, and all of this stuff that the cloud entails? So let's dive right into it. And if you want to, you can run this cell, sign up for our newsletter. We push like bi-weekly to monthly updates, all topics of data science. We also have like a really active Slack community members channel with around 500 people in there. So feel free to join. And just to set the background, so in this example of running parallel experiments, under the hood we are running notebooks. We took a notebook, we templatized it, and then we pass parameters to it. So we will see how we train random forest, and we can change the classifier, we can change the level of the tree that we get into. All of this is being done once we wrote the code into the notebook, and then we can just like parameterize it from the outside. This is an example of data analysis. So what we can see here, let's go here. And obviously, like, we can execute the cells. It's a Jupyter notebook. The first cell explains a bit about the structure behind it. So under the hood, I don't want to dive too much into it, but we can see here we have a task, and each task has a name. The name is parameterized. So we have the model type, the estimators, the criterion, and the max depth in the tree. And each task, you can think about it as like individual task that you are running as part of a direct acyclic graph DAG. And basically, each of these is the same code with different parameters that we inject from outside. And you can see we have the inputs, which is the source code. It fits IPyNB, it's a notebook to fit the model. We have a grid feature. This is where we specify the parameters we are passing to it. So model type, we're doing the random forest classifier. We have 5 different estimators, 3 criterions. All of this is like 5 by 3 by 3. So we are training around 45 different models. And behind the scene, we are using some capabilities of paper mill. We can also pass in parameters. In this case, we want to do profiling. And we can also specify the outputs, which are products. So in our case, we'll have two outputs. We'll have the model pickle file, and we're gonna have the reports as notebooks. So whatever we run, we can actually see the output notebooks and see the exact outputs in each cell. So after we pass this tag, we can execute the next cell. This gives us the status of what we created. Compute it for a second. We can see it gives us a nice table of status for each task that we have. We can see none of these is run yet. We can see the name, we can see the actual output, and where it sits in our machine. And then we can go and actually execute it. So let's go scroll to the bottom of the table. We can see here we have 45 tasks. So if you remember, we had 5 by 3 by 3, that's 45. And now we can run it. Now what it does, it will take like 30 seconds to a minute. It takes all of these notebooks, it parallelizes it locally, and one second, read that it's 0. Yeah, maybe it takes a while. Not sure why it doesn't build. Does anyone else experience that?
Yeah, it's running.
Oh yeah, it's running.
Just that it's slow.
Yeah. Yeah,
Small
maybe.
instance.
Yeah, so it's a small cluster. We are like, what, 20, 30 people who are running together. So for this example, it's a bit slower. But what we do, now we run in parallel. All right, cool. So yeah, I think maybe the cluster broke.
We can run it locally. I have it ready. Let's
Yeah.
switch to my laptop.
That's fair. So what we'll do now, I guess, did it broke to?
Yes.
Okay, cool. So let's do this. Let's run locally. Just clone the repo, go to the folder, install the requirements, and open Jupyter Lab. And we'll switch to Eduardo's laptop.
Shall we wait for?
Yeah, let's give like 2 minutes for everyone to set up their environments, install the requirements, and get back the instructions. Someone needs it.
Was anyone able to run this without issues in the link?
Right on the server and
Okay. You
After
would.
reloading, I think it's working again. After just loading the website.
So now it's gone.
Yeah, it happens with the Wi-Fi.
Okay.
now actually it's building, yeah.
Okay. Well, maybe you can try again and see if it works, because we ran a workshop with about 15 people and it worked.
Yeah.
So maybe it was some Wi-Fi issue. Here. So So if anyone needs help, let me know. If you are unable to install things locally, you're getting some issues, let me know. Or if the cluster is breaking. virtual environment is one second.
How many of you got it working? One. What's that?
Locally or?
Locally. Yeah, I think like online, I don't know, for me it crashed, so maybe we shouldn't run online.
Like,
Yeah,
the Rico,
okay. I will see you.
allows me
To clone it?
to clone it on my edge node, yeah.
Maybe just, can you download the zip and then I'll zip it? Cool.
Yeah, I can try that, yeah.
Yeah, because I think connected to like a machine.
Yeah, let's start.
I think we can run it locally on the laptop.
You know, here. Go.
Yeah.
I can just give you the URL. That's what it's. So people.
If you want to do this,
Install.
try to go.
Oh, yeah.
What's that?
Break. I don't know.
Go ahead.
Will be more successful. How do I say the parents is
Terminal. Taking so.
Talk to gentleman in New Jersey. Oh,
okay. So it should work.
Yeah, if you
Yeah.
Stable
it's
stuff.
not
And what names?
Well,
So you could wait from home.
now we have this.
I work remote from New York, so. Okay.
Yeah, it should be.
You live in the city?
I don't.
This is
No.
train. So anyone having issues? Okay.
That same
thing,
Yeah, I have done it before.
With the output? You can. Okay.
Okay.
You also get
Do you have Jupyter? Because there might be
Oh,
some
could be,
issues.
yeah.
Yeah, VS Code.
Alright. Yes, you also get this annual. So it gets stuck to like on 35%.
The running the
Yeah, the pilot.
Just switch the executor to the serial one and it should break. Let's see if that works.
Oh, so it kind of looks like a issue. Well, let's go for it.
But that's the notebook.
She also
Yeah, okay. They love those.
yeah, I agree.
Yeah.
Yeah.
Looks like it's not too much.
So normally you open, when you open it,
Install like programs.
I'm not able to run locally, so I'm trying the binder again.
Okay.
Um,
Yeah, you do that.
So it's,
PyData
I
NYC.
started that build,
I saw that.
nothing is happening.
Yeah, it's possible maybe because of
To
the
the
yeah, I can check again, but like I think
Okay, it's not.
I think there's some issues with that notes one by one.
Someone's not working the notebook. Start.
I
I go to the directory.
Or stuff.
And you didn't open them and then do.
Yeah.
Yes. Yeah, CD to
I can just use that.
PyData, wherever it is in your.
I see.
It's not that.
Wait.
Yeah, weird.
Wait.
Now, notes, just gives you.
What's this?
And then it starts from the directory.
Switch to the second part, which is debugging. So this is good.
Yes.
But it's an user memory.
Yeah. Just for that context.
Now it sorts the website out, and then it in the directory.
Right.
Cool. If
It's about
Yes.
All right, so
you do it from.
it appears there's some issue that the developer will solve like offline about parallelizing the notebooks. What we can do, some of the sections are independent of each other. Let's go to the section where it says debugging notebooks, and we'll start from here till the break, and then after the break we can go back and continue what we did with parallelization. So everyone, please scroll down. There's a lot of like plots over there, so we can do it together just so you see. So we were over here at that build, and we can scroll down, go over all of these plots. Pass the SQL with notebooks, and then go to debugging notebooks. So here we're going to talk about this use case where we just mentioned, let's say now we're training a model, super heavy, running like 400-500 gigabytes of data, and it breaks. We come in the morning, Monday morning, it breaks, we train it over the weekend, lots of compute power loss. What do we do now? Do we debug locally with a smaller sample? Do we actually execute it, a smaller model, a smaller version? And what we're gonna see here, it's a tool called Debug Later. We published that like I think 6 months ago, and what we're gonna see here is how we can have a different process on top that grabs the notebook, and it throws all the stack trace of the notebook. So we can start a debugging session via Python and understand exactly what's going on. So let's run the first cell. We can see it has a different pipeline YAML. Just if someone missed it, so the pipeline YAML actually defines our DAB. Basically, it's one task that grabs a notebook, has input and output, and what we can do over here, basically it's a shell command, so we can run it as part of the CLI, and we are running Plumber build, giving it the YAML file with the flag debug later. And if we want, let's go to the pipeline and exactly see what's going on there. So let's go to debugging. Let's go to the pipeline. We can see that the source is the notebook pipeline B. Let's open the source. So we can see like we are importing, there is some parameterization over here, and then what we have is, division by 0 causes an exception, everything breaks. And let's go back to our main notebook. We can see exactly where the error happens. Exception happened in line 7, in cell 7. Tells us the exception, and then we can debug a session on this notebook. So what we can do is we can open a new terminal window. Let's go down a bit. So we'll open a terminal window and call the command dltr. You can click on this folder, click on this plus sign, new launcher, and then open a terminal. And we'll need to go to this folder. So we also have the instruction here, so I can use this. Here, let's open a new terminal. Okay, so we are already in the folder. We're already in the debugging level of it. We're gonna have the notebook done. I think I'm one level too deep. Let's check. All right. So we can see here the notebook dump file. That's where we say that stack trace. We can do dltr notebook file.
To activate the environment.
From that, activate EMP or convert it.
All right. So now we started a debugging session. We have exactly the state that the notebook had, all of the parameters. So n works like a notebook. If I do x, I can see x is 1. And just to remind everyone what happened, we know it's cell 7. Execution happened here. So we can print x, we can print y, we can do right. So we can print the data if we want to do whole data frame, 2 columns. And if we'll actually do x divided by y, we understand what's going on, that's an error. We can fix it in the notebook, which is the next step. So let's fix it and rerun it. Go to the notebook, change y to 1. You have on the top, you can do save. And now let's rerun it. It's part of the workshop. Done. Let's go here to the L. Yeah, and now we'll see run, won't fail again, and we'll have the report in the end. So this is like a really powerful tool. It tells you, okay, so it ran, the name, how much time it took, and if you get stuck in production, that's a nice tool you can use to ease things out. And the next thing we want to talk about is the notebook profiling. So we have another tool called mprof. It actually helps you profile your notebook, see how much CPU it consumes, how much RAM it consumes. And that way you can optimize. Let's say you have a notebook that runs a really heavy cell. Maybe it could be like a SQL query or something like that. that's one tool to understand where is the bottleneck, how do I solve it, and where to focus on, basically. So what we'll do here, a command called mprof will run papermill on this notebook. And so we can see that the input notebook is notebook IPyNB, the output is temp IPyNB, and once it's done, it generates a plot for me, so we can see exactly how much RAM or CPU each notebook consumed. Give it a second.
Yes,
All right, so here we have the plot, the memory used, and the time it took to run. The first example where we used papermill, it's actually running on its own process, so it isn't capable of like profiling the notebook. And then we can have these plots and run it again and again. So what we can do, let's run this one. So you can run the cells below. Here we can see, it's papermill, it runs one notebook, and once it's done, we don't have like a really specific per cell distribution on the memory and CPU. If we'll run the bottom ones over here, for a second, so it's loading, you can see that the curve is no longer flat, so we can see the cumulative time of each cell and how much memory it consumes. So we can see the first part here is linear, and the less cells are mostly plots, so it takes less time in memory.
And just to give some more background on why there's a difference between the two plots. So in the first case, what either run is just the papermill command, right? And has anyone used papermill before? No? Okay. Well, papermill is a command line tool to run notebooks. Essentially, you pass the path to a notebook and it runs it from your command line, right? You can use that to generate reports or just like run a notebook from the command line. Now, the main limitation of papermill is that it spins up a second process. So you have your papermill process and a second process that runs your code. And these two processes communicate. And that's how Jupyter Lab works, right? Your UI is running, it's just sending messages to another process, which runs your code and gets the results back. That's one limitation of papermill, and you can see that such limitation reflects here because we don't see anything, it's just constant. The memory usage, because the main process is just sending messages back and forth. So what we did is we fixed it by creating our own executor, which executes the notebook in the same process. So if you monitor that process, you'll see memory usage, which is what we see here. Right here, we can see that the memory, and actually, if we take a look at the notebook, it's a really simple notebook. I'm just loading a NumPy array and then loading more and more and more. So you can see here that we are stacking up the memory. So if you use papermill, you won't see these, you won't be able to profile your notebooks. If you use our notebook executor, you'll be able to do it. So just to emphasize this difference, so you don't get confused if you use papermill and are unable to do this profiling.
Yeah, and I think maybe let's stop for questions, if anyone has questions, and then we'll take the break. I think it's a good checkpoint. So anyone has questions so far?
I'm sorry, does this need to run in a certain environment?
What's that?
Does this have to run in a certain environment?
For the monitoring
the notebook. For the notebook, yeah. The workshop.
So we're running locally right now.
Yeah.
Started in a Binder cluster, but you can run, it's like a pip install. And
okay.
Yeah.
Thank you.
Mm-hmm. Any other questions?
Yeah.
On the profiling, can you identify which cells will take more time, or?
That's a great question. We haven't gotten into those details. It sounds like if that's something that people need, we may work on that. Because here you only see the time, right? time in seconds, but it's not simple to match time to a cell. So I think that's kind of the next step for this project, to have the axis, the x-axis, to be like cell 0, cell 1, cell 2, and that will give you a lot more detail to know where you're using the most resources. Because the most common issue here that we heard from clients and users is they spin up a machine in the cloud, but it's really difficult to anticipate how much resources you're going to use. Because you may have a 1 gigabyte data set, but if you load it in pandas, it blows up like maybe to 2 gigabytes. If you copy data, it blows up to 4, 8. So you may be using an instance that's not enough, and it becomes really difficult to fix it if you don't know which part of your notebook is consuming the most resources.
Okay, so here you would use you would look at the total memory use, and it helps you anticipate like the memory you would need.
Yeah,
okay.
Yeah, like that's kind of a practical use case for this. You could take a look at this plot and see, okay, this is the maximum that I'm using. So now now I know which instance I can use that will run my code.
Anyone else? All right. So let's take 15 minutes break.
Let's make it 10, maybe.
Yeah. What's the time? Yeah. Let's make it 10. 10 minutes to 10.
And if you have questions, we'll stay here.
Yeah, we'll hear anything you want. We'll stay here. All right. See you in 10.
I didn't realize my arrival would cause applause. Do you want to head out at 11 to go to cover the registration desk? But they let me do it. Can you do it? 11 o'clock. Yeah.
11
Registration desk downstairs.
To which time?
To 1. No, could you do to 12?
No.
Woohoo! Okay, that's fine. All right.
Can you do that?
Yeah, because we got another one.
Okay, so you can do 11 to 1?
No, I mean,
Oh, second set. Okay, so you do the second set, and then you just 11 to 12. Okay, thank you. Because I had a couple people, they canceled at the last minute, so I got to get them. Yeah,
if you need me for 12 to 1,
I will probably need you for.
or later in the afternoon.
Yeah.
I have to do later in the afternoon, from like 1 to 3.
Let's see. So where I don't have coverage. I don't know about her. Yeah, so it would be probably 12 to 3 because these folks aren't here, and luckily Yassim and there's someone else who can do it until 11. If you can do 11 to 12, that's perfect. And then I just have to find some more. And then you said you're free. Yeah, I may need you from 1 to 3. Let's see. So Carolyn, who's my name? Marjorie. I may still need you here though because Marjorie was not able to make it. Oh, she's over there. Oh, okay. All right, find out. I'll be right back.
I'm sure.
She'll be here for the afternoon session, so I'll probably need you downstairs. Yeah, that 1 to 3. And then 12. So Nurgle would go to 12. Yes, so that's all right. Thank you.
Affects behavior, but that also you have the knock-on effects that go the other direction, and then it would affect Right, exactly. And trade-offs.
I was here.
Yeah.
I was here.
Well, how's it going?
Main level, where the notebook. So it's not in the debugging.
It doesn't matter.
Anyone has any questions or need help? No, we're good. Okay. We'll be here if you have any.
Yeah.
So I should be in a good shot.
Okay.
Yeah.
How do I create one? I guess that's part of the stuff.
Oh, got it. So if you go up,
Yes.
the way we export we run the build, with the debug mix. That tells the serialized dump in something great.
So essentially, Jupyter represent
Yes.
I usually just my main
Yeah. So if you go to Windows,
and there's this really nice receipt.
notebook icon, that's the notebook you're actually running. If you click on output,
So the notebook is not
so it does an exception in line 7.
So
So no, if you go down, and then the notebook
cells
So I'm actually
because the Python cannot store the outputs, right? So that
yeah, and
means
that's where like
that
when it fits the
Python, it just becomes like a
because I'm not actually
and then if you want to use paper, there's no language can also if you use Prompt, you can execute MySpace directly. If you use paper, you can convert
yeah, it's wrapping the notebook.
and then this new
Yes.
and that's where notes said data versus stuff done.
Yes.
Yeah, it's like the process knows when something fails, it doesn't throw an exception, it actually saves
Don't always find
it. Saves
those
it.
tasks.
I need water, turn it, and then execute. So you have
Yeah,
an output
100%.
your source code is still there.
Awesome.
Essentially,
With a lot of good work,
if
thank you so much.
anything breaks, you have sale by sale, the outputs, and often your data, if you are working on machine learning data science, often text logs are not enough. And you want to put that in a so if your notebook breaks, then you have a full record. So that's why we use and we have production, not much, not really because we want people to have to not this and
So-
run the code and do whatever they want. But
Yeah,
because
so
they help you
first
work
like the first
faster.
inspiration.
And they say,
Because you're like
and then
usually
index data, and then you know what you want.
so like this is one example. So profiling, so
Logs and tables, and you
Um,
can use that for
cloud, for example, like we could see the next section helps you like schedule. Like let's say your machine is strong enough, like yeah, exactly. Yeah, exactly. So it's like exploration.
Well, that's a fair point. I would say that output cells should be temporary. Like if there's a need to reconstruct the outputs, you can put them on version control or an S3. But many times you just start using the code and turn them to the mobile.
We do see
I would say that
are,
for
example,
store those up.
some
That should be like I execute the code and I which commit I use for the software and then I store the output of the S3 and that's kind of because anything that's not reproducible, like should not be versions on a Python. Maybe you won't be able to reproduce the results, so you have twice store. I feel like it should be
exactly.
mutable.
It doesn't
Those should be versions.
Generate Python code or scripts separate from them. Every time you save it, it'll save.
Yes, and this is the orchestration, right? Like this is how you find this, you know, like all
and I feel like
double brackets.
we also have
Step by step, but once I have it, the
Customize.
process worked out.
In this case, it's very important.
Script, like I'll just run a script for the
Doesn't have
run all cells.
Yeah, it could be like 20, 30 nodes.
those are
Running in parallel.
Those are things that
It's also running in parallel, but it's like one node, so it's like
something that's
straight
really
line.
for ability to run internal apps that should not be considered an experiment because there is no simple way to rerun and recreate. Yeah, so why bother about those outputs if it's going to be
complicated to reproduce. It's a bit strict what we
that's a
advocate for, but I think it's the way of the best way to do it. Yes, that's going to be part of one of the sections where we show how to compare plots.
Yeah, so we'll have like the email and we can add this.
That won't change. Yeah, 4. That's right. Huge.
The idea is it's really not how.
Oh, I see.
Just
If you're running from where you were originally running, it's directly parallel. You should troubleshoot to find that problem.
I remember this problem.
Yes. Thank you so much. Sorry.
I have
Yes.
But now, which means it's processed against
Yeah.
so it has to be.
Right. Can you see your page? Okay, good. So we are going to start now. We just figured out this scikit-learn issue. So I saw a couple of people had a key error with log loss when running the models in this. Let me go back to the cell. Here. So I saw a couple of people that had an issue with back.build and key error log loss. So we figure it's a problem with the compatibility of scikit-learn. So please upgrade to the latest version. So let me quickly show you. Yeah, so we just upgraded to 1.13. And the one that was breaking was 1.0 point something. So it looks like they made some changes. So if you're having this issue, I'll show you how you can fix it. Just you can create a new cell and then do pip install upgrade. So I'll show you this large format. And then to verify that you have the latest version, so I'll run this. I don't think it will do anything on my environment because I believe I have the latest one. Yeah, okay. Then please restart your kernel If you're running this in the cloud, it's not necessary because you should not have that issue. It's only if you are running things locally. Now, after restarting the kernel, you can do import sklearn, and then sklearn dot double underscore version double underscore again, and you should see something like this. You don't, most likely you don't have to have this specific version. My guess is that as long as you have 1.1, it should work. But if anyone still has this, I think the error said something like key error log loss, something like that. Something like this. If you still have this issue, please let me know or let Ida know, and we'll help you upgrade. But hopefully you'll be able to do it. And you can still try to open the cloud environment, see if it works for you. So yeah, hopefully everyone will be able to run the examples. Right, so Ido covered the debugging part of it. Now we'll go back to the initial section, which is running experiments in parallel and then analyzing those results. Okay, so now I'll just mention this again in case anyone forgot. So what we have here is a pipeline YAML file, which is the kind of the input for our framework, which is called Plumber. And here we specify what we want to run and how we want to store the outputs. So if you look here, you'll see that we have source and we say feed IPyNB. So that's the notebook that we are going to run. Now we want to turn this into a grid of experiments. We are actually going to generate 45 experiments, and we want to be able to organize this because each run will generate a copy of the notebook and the pickle file, which is the model that we train. Now, since we are going to be training a random forest with multiple parameters, we want to know which report and which pickle file corresponds to which parameters, right? Because we want to find the best one, and then we want to take that pickle file and deploy it to production. And this is just a machine learning use case. We may have something completely different. For example, we have many Plumber users in the bioinformatics field, and they are not doing machine learning, they are doing more like statistical analysis. But they also have to find parameters and tune parameters and then check how those parameters affect the plots that they have or the statistical tests that they are running. And what they do is they do something really, really similar to this. They have their parameters and then they run the same notebook with all of the parameters. Now to organize our outputs, we have these placeholders. These ones that you see on the square brackets, and these right now look like, these are templates. The moment we run our notebooks, these placeholders will take the values of the parameters. So I can give you an example. We have a few parameters here. We'll train a random forest. We will change the estimators number with 3, 5, 10, 15, 20, the criterion, and the max depth of each tree. And for example, for our first experiment is 3 estimators, criterion Gini, and max depth 5. Well, that's gonna translate into having a notebook in the output reports model type. That's gonna be random forest. Number of estimators equals 3, criterion equals Gini, and max depth equals 5. So then we'll be able to identify which notebook and which pickle file, which parameters they correspond to. All right, so next cell, this one is loading our pipeline YAML file, which you can see kind of as the configuration for your experiments. And now let's hope things don't break. And let's first generate the summary. This long table is a summary of your set of experiments. So we see a bunch of information here, the name of the experiment, if we run it already, we're storing the output, and then the source code location. So here, the source code is gonna be the same because we have only one notebook. But we could have multiple notebooks with dependencies, like I want to run this first and then this one after it. But here is a really simple pipeline. Actually, I'm gonna show the plot because we did not show it before. So you can see how it looks like. Just store it in one file. let's call this plot. I think it should be D3 HTML. All right. Now I should have one new file here. All right, looks like it's not visible because we have too many nodes, too many experiments, but that's fine. We can see how many experiments we're gonna run, so it's 45, and now I'll run the whole thing. May not run anything, okay, yeah. So this is also one feature that Cucumber has. Since we already ran the experiments and we did not modify the source code, it's caching the results. So it's telling me there's nothing to run because you already ran these experiments with the same parameters. Now this can help you a lot if you are modifying parts of your pipeline, because there is no need for you to rerun everything, right? You can think of this as kind of make. If you have used it before, it's really similar. And if I go and change anything in my notebook, it will say, now the source code is different, so I have to run the whole thing again. And we see the summary of everything that it ran. Now I'm gonna show you the output. And here we are going to see exactly what I mentioned earlier, right? So we have parallel output, and inside that folder we have two folders with lots of files. One folder is called models, and we have all the pickle files there. And the other one is called reports, and those are our output notebooks. So if we go to models, we'll see a bunch of files, and we can see that this random forest corresponds to 15 estimators, criterion, entropy, and max depth of 100. And then we have the pickle file. And if we want to know, for example, what's the performance of certain random forest, we can go to parallel, output, reports, model type, and then you can choose from any of these. Let's see, for example, how n estimators equals 3, criterion Gini, max depth 10 is performing. So this is a copy of your notebook. This is not your source code, it's like an output report in notebook format. And you can see the source code here. We train a model and we have a bunch of plots, and we can see how this model is performing. We have the confusion matrix, which allows us to evaluate this classifier, false positives, false negatives, true positives, and true negatives. And we also have the classification report that tells us few important metrics like precision, recall, F1 score. And all these plots we are generating with a package called scikit-learn evaluation, which is something that we did. And it has a bunch of other things. I can show you quickly the kind of the plots that we have, or a bunch of them for regression models, classifiers, clustering, so you can see a calibration curve. We just added this last week. The classification report that I just showed you. This is also a classification report. Confusion matrix, the one that I showed you. Elbow curve to evaluate clustering methods. What else? Feature importances. So we have a bunch of things here. You can check out the project. It's pretty nice. All right, so let's continue with the main file. Let me go back here. Okay, so we were talking about the file. So I'll move to the next section. But before I go to the next section, anyone has questions? Did anyone have issues running the models? No? Okay, we're good. Question here?
Yeah, the guy who wouldn't know.
Okay, let's, can you? Yeah. All right, so now, I mentioned that we have, we actually have 45 output notebooks, and you can go and click on each one of them, and you can visualize the performance of each model. But that's not really convenient, right? Imagine like going through 45 notebooks, that's not something fun, so we have to figure out an easier way to compare these models. And that's what I'm going to show you now, how we can easily compare multiple notebooks in the dozens and also in the hundreds of notebooks, because you might be generating hundreds of experiments. So the first thing that I'm going to show you is what we developed is notebook collection. That's also part of the scikit-learn evaluation package, the same thing. Notebook collection takes a list of notebooks and then it extracts the output cells so you can visualize them in a single node. So I'll show you how you can do it. The first thing is, this is something that we did already, but just for completeness, the way we identify the plots in a notebook so you can visualize them later is by creating a tag on a cell. And you can see here this animation. I click on a cell, and then I click on that button on the right, and then this cell tags menu appears. I show this because this is something that we realize many people don't know you can do. So when we say cell tags, it becomes a bit confusing. So you're essentially tagging a cell and giving it a name. So I have a confusion matrix here, select the cell, click on this cell tags menu, and say, I want this cell to have this name. That's all it is. So now if you do that and you run the notebooks, you'll be able to extract those outputs using a notebook collection. You don't have to do it because we did it already for the example notebook. Now, if you run the next cells, so I'm going to import a few things here, and then I'm going to print this, so the paths. So you see I have I'm expanding, I'm essentially asking Python through the global feature to give me all the random forests that have n estimators equals 20, right? That's kind of the query that I want to run on my experiments. I want to analyze how the random forest with n estimators equals 20 behave. And this is returning me a list of all the notebooks that match that criteria. N estimators equals 20. Now I have a little function here that will extract the parameters from the path, because I have a few of them. I have n estimators, I have criteria, I have max depth, and that's it. So that's what this function is for. Now I'm initializing my notebook collection here, and I am passing the paths to those notebooks, and then assigning some IDs just so I can easily recognize them. Then if I do list collection, it will print all the tags that it found in a notebooks. So I see that I have a few things that I can extract from all these notebooks. Estimators, criterion, max depth, accuracy, precision, recall. These are just numbers and strings. The plots are these ones: confusion matrix, classification report, and precision recall. So now if I do collection, this behaves like a dictionary. So if I do collection and then pass the name of one of the cell tags, I'll be able to compare the different confusion matrices. So you see the first one is criterion equals entropy and max depth equals 10. But I can click on any of these buttons and you'll see that it changes. Right, so I am going through all these confusion matrices, and then I'm able to compare. And you can start to see the patterns. For example, if let's stick with criterion Gini, right? If we go with criterion Gini max depth of 5, we see these numbers. We see that we are making a lot of mistakes in our classifier because we have many observations here in the top right and bottom left quadrants. Now, what happens if we stick with criterion Gini, but increase the maximum depth to, what's the next value? I think it's 10, yes. Okay, so this one. Let's compare to the other one. I think this quadrant is getting a fewer observations. Yeah, so we went from 596 to 508. That's an improvement, and that's kind of telling us that this parameter is having a good effect on the model. Now, what happens if we increase the maximum depth to the maximum value that we use, so 100? You see that we even have fewer values here, and we have more values in the upper left and bottom right quadrant. So this is kind of the objective of this library, to allow you to experiment with parameters and then easily compare them. Because otherwise you have to maybe create a single notebook that has a gigantic for loop and tries all your parameters, and then it becomes really hard to organize your plots and compare them. And we can also get other plots. We also have the classification report, and it's the same story. We can just change and click on these buttons, and we'll be able to see how the parameters are affecting the model. And as I mentioned before, this doesn't have to be for machine learning. You may have other types of plots, and you can still do the same thing of clicking on them and seeing how the different parameters behave. The final plot that I have is precision recall, and same story. We can click on this and see how the plot changes. Now, this is convenient for, let's say, a dozen experiments. But what if you have 100? It becomes a lot more difficult, because imagine if you had 100 buttons here. It would be really hard to go through all of them, right? So how do we scale when we have hundreds of experiments? That's what I'm going to show you now. Well, the answer is, or at least our answer, you can tell me if you think we are going through the right path. There's a really popular language for querying data, right? SQL. Like that's what you use for databases. That's what you use to run analytics. So what we did is maybe kind of like a crazy idea, but I think it's working. Our users like it. We ask ourselves, what if we query notebooks with SQL? What if we treat notebooks as rows in a database and we just query them with SQL so we can compare the experiments? And the motivation for this is when I was working as a data scientist, I was using many of the existing experiment trackers and I did not like them because it kind of felt like they put so many restrictions on how I can explore my experiments. They come up with their own query language, or they only have a graphical user interface where I have to click buttons and figure out how do I aggregate my experiments. And I thought, well, SQL is the best way to aggregate and express transformations on data. So what if we do that? So I actually created a small POC back when I was working. And then when we started working on Flutter full time, I decided to put more time on it to add a few more features. So that's kind of the idea. The idea is how can we efficiently explore these notebooks? And we are using SQLite because it's a really nice database. It doesn't need any installation, it doesn't need any servers, it doesn't need any configuration. And now I'm going to show you the notebook database. So we went from notebook collection to notebook database. Notebook database takes this pattern, like a globe pattern, and it will go through each notebook, extract the outputs, and then index those in a SQLite database. So let me run this. All right, now I'm loading JupySQL, which allows me to run SQL directly in a notebook cell. You can also use pandas for this. It's just convenient. All right, so it indexed the notebooks already, and it created this notebooks.db file. And now, since each notebook may have a different set of cells that we store, it stores everything in a JSON object, right? So that's, and conveniently, SQLite supports JSON, and you can do this JSON extract, and then you see that my query is extracting the number of estimators, the maximum depth, the criterion, the accuracy, recall, precision, and F1 score. And this is the magic of SQL, that I can do all kinds of crazy things with my notebooks. And let's say that in your use case, you are working on a machine learning model and you determine that F1 is the best metric for your use case. Well, you can easily order by F1 and see what are the top performing experiments. And here it is. Now your notebooks became rows in this table, and you know that the one that has the maximum F1 score is the first row, and it has 20 estimators, maximum depth of 10, and a criterion of logos. And you can see the other metrics as well. And we can also use pandas for this. Here I'm running the same query, but using pandas.read SQL query. So let me run that. And the df variable becomes the output of my query. Now, since this is already in a data frame format, I can start plotting things. So that it's really powerful because I can use SQL to extract the experiments that I want, and then I can use matplotlib with pandas to start getting some insights into, like, making sense of these numbers. And I'll show you an example. So let's say I'm interested in the effect that the number of estimators has in accuracy, right? That's kind of the question that I'm asking myself. Is increasing the number of estimators having a positive or negative effect on accuracy. And you can start asking all kinds of questions to your experiments, because you can use SQL, right? You can aggregate, you can transform the data, and then you can start really taking a deep dive into your experiments with SQL and with these tools. So what I'm doing here is I take my data frame, and this is actually reading all my experiments. If I do df shape, let's do df.shape, I see 45 rows, and that corresponds to the 45 notebooks that we run. And now you see this code. So I'll walk you through it. I am importing matplotlib, and then I am grouping by number of estimators, all my experiments. And then I'm taking the mean of the numeric variables, because I'm interested in seeing the mean of the accuracy metric. Then I have these 3 lines of code that plot in the x-axis number of estimators, and in the y-axis accuracy. And you can see the trend here, right? When we start, I think we have 3, right? 3 is an actual value. It has 0.70 in accuracy. The moment we start increasing the number of estimators, we see that the accuracy is also increasing. But it doesn't, like here, for example, when we go from, I think the actual value is 15. When we go from 15 to 20, we don't see much of a change. It's like getting to, like increasing just a tiny bit, and that already gives us some information for our next experiments. If this is taking too much time from our computing resources, let's imagine this is a deep learning model that takes 7 hours or 8 hours or 12 hours to run. If we see this, we'll be like, well, I'll just stick with this metric here, and I won't go over it because I'm just wasting computing resources and my time. So that's the benefit of having SQL as your language for analyzing your experiments. Because you can ask all these questions and you can create these plots and inform your next set of experiments. And that's kind of the takeaway from this workshop is you can use notebooks as experiments, then you can analyze those results, and you can come up with new ideas to try a new set of experiments. And you repeat this. And this workflow is something that everyone that analyzes data does, like data scientists, machine learning engineers, data analysts, people that are doing scientific analysis. It's a really common pattern that you have to tweak these parameters and understand what are the dynamics of your data and your models. All right. Now that covers this part. Anyone has any questions? No, all good? Okay. Now for the final part, we'll go through, I'll show you how you can scale your experiments. Okay. In the section that I just described, when I was generating these 45 experiments, I ran all of them in my laptop. And I was able to do so because this is a sample data set. I think it has like 10,000 rows, like a very small data set. But what happens if my data set is, let's say, 4 gigabytes? A file, a Parquet file, or a CSV file that has 4 gigabytes. If I'm using my laptop, maybe I'll be able to run 1 or 2 at the same time. And if I'm running 45 experiments, it's going to take a lot of time for those experiments to finish. And now the idea is, how do we scale this to a cluster? How do we benefit of cloud computing so that we can do the same, have the same experience, but with more resources? So the first thing that I'm going to show you is Bloomberg Cloud, which is our service, and there's a free plan for researchers and students. It allows you to quickly run thousands of experiments in the cloud without changing your code. So if it runs locally with Bloomberg, let me show you how we run these 45 experiments. We did DAG build right here. And you can also execute this from the command line. If you do it from the command line, it would be Bloomberg build. I'm not going to run this now, but if you go from Bloomberg build to Bloomberg Cloud, well, you first have to set your API key. So please, if you want to run this in the cloud, You can find the links here, so you can get your API key and actually run this in the cloud. As soon as you have your API key, you can run these commands and you'll execute those 45 experiments in the cloud without changing any line of code. Let's say I already set my key. I go from Plumber build to Plumber cloud build. That's the only change that I have to make. And this will take my notebook, parameterize it, allocate 45 containers, run the notebooks, and then put the results in S3, and then I can download. So this triggers the execution from the cloud build. It uploads my source code, then I can monitor the execution. I can check the status of these 45 experiments. Actually, didn't run the whole thing. But you can see when I run it, it says finished, meaning I finished executing all the experiments. And then I can download the outputs. So I can do Plumber Cloud download, and then I can download all my outputs, and then I can continue working on my analysis. I can do the same thing that I did here of comparing my plots. Where is it? Here. Can download my remote notebooks, do this thing, and also use the notebook database, start using SQL, and now maybe have 1,000 experiments that I run in the cloud. Now, if you are not able to use a cloud service, because we know many companies have restrictions in terms of where you can run things and put your data. Plumber Cloud is mostly open source. What's not open source are some of the optimizations that we do, but you can deploy these on your AWS account. And we recently published a step-by-step tutorial showing you how to spin up a data science platform on AWS. Essentially it has all the commands that you need, right? So literally just like run this command, then the next one, then the next one. And it's three parts. By the end of them, you'll have something that resembles Plumber Cloud. And you'll be able to take your notebooks, parameterize them, run them in AWS, scale up and down, and only pay for compute use, right? Because you spin up the dependencies, you run your thing, and you shut them down. So that's how you can use it. We have a pre-active Slack community, so you can ask us any questions about the configuration for Plumber, for AWS Slack, for Plumber Cloud. We'll also be here. So if you want to talk to us here or like later, you can ask us any questions. That's all I have. Oh, if you want to sign up for the newsletter to get any product updates in terms of what we are building, you can put your email address. You first have to run this, and then you'll be able to put your email and subscribe. And that's it. Does anyone have any questions now? Yeah.
Just a little one. It seems like so you have the tagging interface when you're doing a smaller number, and then you kind of move to the SQL interface when you start to get a large number of experiments. Can you still use the tagging filtering and stuff like that for anything once you've kind of reduced your set with SQL?
Yes, that's a good point. That's actually what we've been working on last week.
Okay.
We haven't figured out what's the best API, so if you have any tips, I would really appreciate it. So what we are doing is, what we want is allow users to use SQL, but as you mentioned, maybe you narrow down your experiments to 5, so then your SQL query can output something like, where is it? Here, yeah, like this. So you go directly to SQL, because that's the most powerful interface. Well, we will still leave this because people use it, but that's kind of, we want to move to SQL so you have all the flexibility, but still can produce this thing. Another thing that we can do, which that we want to do, but we haven't found the time to do it, is, and you tell me if you think this is a good idea or not, but many times you don't want to put things side by side like this, or like, you want to put them like overlapping. So another thing we want to do is, can we take the confusion matrices and overlap them so you have the numbers for model A next to the numbers for model B? I think that could be really powerful, right? Because it becomes like kind of like an experimentation platform where you can slice and find some experiments and compare one to another, find the differences. So we are also thinking, I think at this stage, we are kind of experimenting with different APIs and asking for user feedback, because we want to get the API right before we go and build it. So if you are interested in this kind of comparison, model comparison, please subscribe to our newsletter and join our Slack, because we are going to be showing some like early stuff to get feedback. Because we think this is a really exciting new development that we have, and we want to get it right because it can be really, really powerful. Yep.
Is it essential that the actual experiments run in notebooks, or could you just have this like orchestration notebook that sets up the parameters for the experiment and then does the cool like stuff you have here to show the results, but it's just like calling Python scripts as it is?
Yeah, that's a good point. So two things. You can execute Python scripts in Plunger, and it will convert those into notebooks, and you have those records. So the same idea, just different format for the source code. Now, if you don't want these output notebooks, we haven't finished that. Well, I can show you what we have. We have something called, that's part of the scikit-learn evaluation package, is, I think it's this one, yeah. So we have something called SQLite Tracker, which is, I think, what you want. It's an API that allows you to add new rows to this SQLite database. And it's agnostic in terms of, is it a script, is it a function? It just has an API that allows you to do, let me find it right here. I lost what I wanted to show. Here, you can insert new rows, and then you can store the metrics or the plots, and then you don't have to use notebooks. Mm-hmm. Any other questions? Okay, I think we have some gift for you for staying with us. No, this is not my black bag. We have the same bag. We always get confused. It's not the first or the last time that it happens. All right, so we have some t-shirts and some stickers, so I'll put them here, and if you want one, feel free to come and grab one, and it's an excuse for you to approach us and talk to us. So I'll put them right here.